Well, hello everyone. Welcome to this brief webinar introducing, having an overview of our software application, our seismic processing application, InSite, focusing on the new features presented in the latest release 3.20, which was released last February, at the end of last February, but also giving an overview of the main features within InSite seismic processing software. At any time, as this is a live webinar, please, you can always use the chat if you have any questions, and I will try and cover them at the end of the presentation. So, whether you're a user or not, you might be aware that InSite seismic processing software is a whole package that integrates data management, processing, analysis, and interpretation of seismic data at many different scales. It's been developed by us, by Applied Seismology Consulting, over the past 25 years, so more than 25 years, and incorporates both internal research and development tools, as well as tools that have been developed in partnership with some of our clients and associates. It applies and it's been used at many different scales of seismic and acoustic monitoring, ranging from lab rock deformation tests, in this case it would be monitoring acoustic emissions, up to the processing of local and regional seismicity. And as I said previously, the latest version is 3.20 and was released last February. And the idea is that InSite covers the full seismic processing workflow. So in that sense, it goes from project setup, the event or harvesting, the detection of events, the import of events that have been triggered, have been detected by third-party software or by hardware applications, then into the processing of waveforms, of course the pre-processing, which we will discuss in the next slide, as well as classifying triggers as noise, shots, or events, and for events into the full processing, including location, picking, phase picking, location, and calculation of source parameters and mechanisms. And of course, the analysis and export of results, which could be exported as an event catalog or as waveforms for further analysis in your own software. For project setup, well, the main step is adding the seismic receiver, so the interface is friendly enough to help aid in a quick addition of these seismic stations or receivers. Optionally, you can also add any geological or engineering structures that aid in the interpretation of your results, because it allows you to compare where your events locate in relation to any object, such as a well, formation, or in the case of the lab, what would be the sample, the rock sample. It allows you to configure your sensors in a versatile manner. You can add 1 to 4 channels per station. You can work with many different responses, such as voltage, acceleration, velocity, or displacement. And in the new release, you can also set up your project by directly importing station XML files, which are available mostly, typically in the monitoring using surface stations. So most of these stations export their own XML file, so that can be imported into InSite, and also allows the multi-selection of sensors when you're working with large arrays. For example, the case of monitoring with fiber optic sensors, where you have a high number of sensor positions, so you can select them to enable or disable, to basically downsample your array in case you want to add into the visualization or into the actual processing of your stream. It allows multiple configurations, such as downhole, surface, volumetric, or a combination of both. I'm just going to demonstrate, very quickly demonstrate, the import of these XML files. And I will open this blank project as we will start. And in this case, yeah, we will just open the edit dialog for the default receiver array, import from file, and we can select the option of XML. You can see here there are multiple options to how to set up our project, such as the dataless seed, sec2, which incorporates the data, the station position itself, or text file. But in this case, I'm going to demonstrate the XML file. Yeah, you just select it, open, and then you need to select which will be your reference ellipsoid used in the creation of this XML file. So I'm going to select the WGS84 because it applies to this particular example, and there you have the stations. You can see if we double click on one of them, for example, that the position has already been set, as well as the relative orientation of the 3 channels in this station. And if we select one of them, it's also imported the sensitivity, basically the gain, the response of the station, the gain, the dominant frequency, and the sensitivity of this particular station into InSite. This is a standard format. I can show you the example. It's in here. Yeah, this is a standard format for seismic data, seismic stations, and yeah, basically includes the response of the instrument, the position of the instrument, the location of the instrument, and the configuration of each of the channels. Okay. As I said before, another feature that has been modified in the latest version for setting up our default receiver array is that you can select multiple channels and edit them if you want to disable one of them, or you can click on this option, which will allow you to enable or disable or enable a range of channels, one every, for example, 1 in 10 channels. This is mainly, mostly implemented for use when monitoring is carried out using DAS, fiber optic sensors, in which you might want to downsample a very large number of channels and disable a particular number of them. Okay. Right, so back to the presentation. This would affect the project setup. Next we go to event data import and harvesting. And well, basically InSite works with any or most of the available commercial file formats, also some proprietary formats for specific clients, but it can either leach, which would be the process of detecting events from continuous stream, or import data in a large number of formats. After import, each of these waveforms is stored as a binary ESF file. This is a proprietary file for InSite, and creates a one file per event. In the next, in the latest release, we have added some stability against blank waveforms, which happen if there's an error in one of our sensors or in one of our stations that produces a blank file. Then we've now added a check in which avoids some previous crashes when this type of files were encountered, and also added a 32-bit range on import. Also, a new option is saving the visualization options to the PCF. By that we mean, I'm going to open an example here. So, for example, when we browse through our waveforms, look at them like this, we might choose whether we want to view our traces, for example, per spaced by order, by channel order, or by position, or for example we might choose to view them per split per channel, etc. Whichever option we select to visualize our waveforms will be saved, and the next time you open the project you will view them in the same way. So that's being incorporated in the latest version of InSite. So moving on, waveform processing, that's waveform pre-processing in this case. InSite does automatically remove the DC component from our traces when importing or leaching them, and also allows you to customize your filter, band pass, high pass, low pass, or a combination of filters, and also individual filters per channel. And also we've incorporated, that was in the last version actually, in the previous version, incorporated the removal of spikes, for example electrical noise, or some kind of noise that affects our traces, that can be automatically removed. The next step will be classifying our triggers into noise, shots, or events. And as a new option, well, we've added a shortcut that will allow to enable or disable, or in fact select multiple components, that's events groups or events, by using the shortcut of Ctrl A and select all. When we go into event processing, the first essential step is the phase picking. And phase picking can be done in multiple ways, can be customized, or in fact automate if you want to do it. But you can incorporate not only amplitude, arrival, but also take into account linearity and polarization of the trace. The next step will be event location. InSite incorporates the ability to work with multiple velocity models, such as homogeneous isotropic, anisotropic, layer, or a full 3D voxel model. In terms of inversion algorithms, it incorporates the option for a collapsing grid search. This is an exhaustive search through all the possible solutions within the space. It's called collapsing because it allows you to optimize this search by doing a low resolution search or low resolution pass first, and then increase the resolution in steps so that it optimizes the time that it takes to locate an event, but also allows you a high resolution and a detailed location of your event. Other algorithms available in InSite are the source scan. This is incorporates a migration algorithm within it, trying to maximize or basing our peak and location in the location that maximizes the energy in our trace. So in that sense, almost can work independently on our peak. It can incorporate our peak if we have it, but if our traces are not good enough for auto picking, the source scan takes care of that and maximizes the energy. So in a way, searches for the peaks at the same time that it locates. And also we have other more basic algorithms such as the simplex or Geiger algorithms. These two don't allow the use of source vectors, in a way they are more limited than the other two, but they are faster, more efficient, and yeah, they are standard location methods. The process of locating events in InSite, it's done by the minimization of the residual equation. That would be the objective function, basically. And compares theoretical and observed travel times and source vectors, and tries to minimize, find the point that minimizes the discrepancy between the theoretical and the observed travel times and source vectors. And by that, yeah, it's how it defines our position, the position that optimizes this or minimizes this residual. The collapsing research, as I mentioned before, it's one of the most optimum location inversion algorithms, because yeah, it starts with a coarse grid, a low resolution search, and then focuses in the areas that give us the best fit and increases the resolution, so the uncertainty at the end it's the smallest as possible, but also it's efficient, it's fast enough to get the results in real time. And after this, the next step will be the analysis and export of results, either as an event catalog or as waveforms. And well, InSite incorporates many analysis tools. For example, shown here are the analysis of the stimulated volume, the volume defined by the active area, by the distribution of our events, allows you to also investigate what's the uncertainty in our locations, and also allows you to analyze the different parameters, the different source parameters. And what's new now is allows you to export the peak particle acceleration, peak particle velocity, and the local magnitude. And also you can customize now the way that you calculate the local magnitude by incorporating the trim media and selectable units. And I'm going to very quickly demonstrate that in the software itself. This is something that you can configure in your processing settings. And if you go to source parameters, if you're familiar with this is a way that it calculates standard source parameters like magnitude, source radius, etc. It's got a specific menu for the local magnitude equation, and here you can fully customize the way you calculate local magnitude. So you can decide what type of amplitude you want to use to calculate your magnitude. For example, vertical component, the mean of the horizontal components, or using the full horizontal components of your traces. Whether the amplitude units you want to use are millimeters, nanometers, or micrometers. Select the different coefficients in this equation. Whether you want to calculate the distance based on the hypocentral or epicentral distance. And of course, this depends on the equation that you want to use locally, because local magnitude should be customized to your local settings. And also now incorporates the option of trim mean. By this, what do we mean? Local magnitude is calculated from all the available stations that you're using. But this allows you to basically to only use those that are within the mean. It calculates the mean for all of them and allows you to take out any outliers so that they don't bias the calculation of the local magnitude. So if there are any outliers in terms of the value of the local magnitude, they can be removed. So by increasing the percentage, so 100% in this case, for example, will cut all of them, and 0% will take into account all of your stations. If you select, for example, 50%, it will cut out any values for the local magnitude that are more than 50% outside of the mean for all of them. Okay, so very quickly to the presentation. There are also some bug fixes in the latest release. So fix some erroneous warning message that was previously shown when on import of CSV files. We have fixed the performance of the Monte Carlo simulation during array analysis, making it more stable and more robust. So there's no crash and no spurious results on it. And also fix a crash that was observed on navigation in between events when navigation was done using a keyboard shortcut. Well, as always, InSite is presented in many different packages. Geo, which is the basic package that it's mostly used for the processing of microseismicity or regional seismicity. InSite Lab, which has some custom tools for the monitoring of acoustic emissions in the lab. InSite HF, which again incorporates tools for working with downhole monitoring or when hydraulic fracturing is used. And InSite Lite, which is the free version for import and visualization, and it's a tool that you can use to share your data, your results with clients or other users, in fact. Okay, so this is a quick overview of the software. As always, please, you can always contact us if you have any questions or if you want a free demonstration of the software or any specific questions. Thank you for your time. And again, please do not hesitate to contact us through our website or our email if you want to find out more about InSite or general questions about the processing of seismicity, acoustic emission, or microseismic data. Thank you again, and hope to see you in our next webinar. Thank you.